Now let's discuss about certain specific terms used in case of heat transfer. For example, we call it black body. So basically these definitions are derived from the property of a body. So as we have seen a case that Q amount of heat was received through radiation, part of it was absorbed, part of it was transmitted, and part of it was reflected back. So a black body is a body when we say that reflected part equals transmitted part equals 0. So basically no reflection, no transmission. So for a black body, so we define a black body as a body which receives Q amount of heat and entire Q amount of heat is absorbed. Neither anything is reflected nor anything is transmitted, and then it is called a black body. If it is reflecting part of it and transmitting part of it, it's no more a black body, and hence this definition of black body is related to its capacity to absorb heat in case of radiation. So if it is absorbing 100% heat, it's called black body. If it is absorbing anything less than 100%, it won't be qualified as black body. Now a very interesting property, a body which receives maximum energy or maximum heat, it also emits maximum energy. Now let's understand the difference between emitting energy and reflecting energy. Emitting energy is different from reflecting energy. When we are talking about reflecting energy, we are talking about the heat it is receiving. With reference to that, how much energy is reflected back. But when we are talking about emitting or radiation capacity, we are talking about its inherent radiation power. So a body kept at temperature T will have its own radiation power. It is radiating heat in all directions. So we are talking about this radiating power when we are talking about radiation or emitting power of a body. So what we say is, if a body is very good receiver of heat in case of radiation, it should have a very good radiating power as well. And that's what the case of black body. So black body is a perfect receiver of heat and a perfect radiator of energy. So let's now discuss something called emissive power. Emissive power and emissivity. So as we have seen, a black body is the perfect radiating body, or it has the maximum emissive power. So for any other body, let's say this is a general body, this is not a black body. So the emissive power of this body will be less than the emissive power of the black body. So what we say is emissive power of the body divided by, or emissive power of the body is equal to a term called emissivity into emissive power of a black body. So if I write EB equals emissivity E into E black body, looking at this, we could say that emissivity, that means emissivity for a black body must be 1, and if a body is simply not emitting any radiation energy, it should be 0, and hence E should be less than or equal to 1. 1 is a case of black body, greater than and equal to 0 when it is simply not emitting any radiation energy. So now if we say that a body has, let's say, 60% emissivity power or emissivity, that means 0.6, and we say, let's say, a black body is emitting 100-watt energy. So what is the emissivity of what is the emissive power, or how much energy a normal body is releasing? So it says 60% of the black body, which is equal to 60 watt. So basically emissivity relates the capacity of a normal body to radiate energy with the capacity of a black body to radiate energy. So when it goes to 100%, a body becomes black body. When it goes to 0, no emission happening, and anywhere in between it will emit certain power or certain fraction of energy compared to a black body radiation. Let's discuss certain properties of surfaces. So let's say we have a rough surface and the another one is a smooth surface. So a black and rough surface is smooth and let's say white surface. So what it has been found is that a black or rough surface has higher absorption power. So A absorption is, let's say here, A1, and in this case A2. So what it has been found is that A1 is greater than A2. So what it means is a black or rough surface has higher absorption power compared to a white or smooth surface. Now what about reflection? A black and rough surface has, let's say, R1, R2. So R1 must be less than R2 for the simple reason that total energy needs to be conserved. If we assume that there is nothing transmitted, so if it is absorbing more, it must be reflecting less. It is not absorbing or absorbing less, so it must be reflecting more. So based on that analogy, we could say that for white or a smooth surface, reflection is higher. For a black and rough surface, absorption is higher, and the other quantity is inverse of that. So with that, we complete the discussion about